All right, last little one here for electric charge and electric forces. In this video, we're going to talk about relating electrons and protons to coulombs. I know we talked about coulombs in the last videos, but right now we're going to figure out exactly their relationship. And then we're going to talk about Coulomb's law and electric forces on how to calculate it. So these are going to be 3 problems that we're going to do. So the unit coulombs is how we measure charge, but it doesn't come from electrons and protons, even though electrons and protons make charge. We learned about charge before we even knew electrons and protons existed. That's why it's kind of a strange unit. Okay, so the first problem that we're going to do is to discover how many electrons are in an object that has a charge of -1 coulomb. Okay, well, the charge of an electron, let's change this to a different color for fun. Okay, so 1 electron is equal to -1.6 times 10 to the minus 19 coulombs. So if I want to find out how many electrons are in 1 coulomb, I would do this. -1 coulombs times the ratio of 1 electron over -1.6 times 10 to the minus 19 coulombs, and that allows me to cancel the coulomb unit to leave electrons. Okay, that's just going back to chapter 1. I wanted to show you that. Okay, so what does this mean? I would take -1 coulombs divided by -1.6 times 10 to the minus 19, and if I did that in my calculator, I will get the number 6.25 times 10 to the 18 electrons. That's a lot, okay? So that's a huge amount of electrons in 1 coulomb of charge. All right, and we rarely see 1 coulomb of charge except inside of your computers or your calculators where you can get electrocuted. You can have as much as 25 coulombs of charge on a capacitor. That's a lot of electrons that can flow into you and cause a lot of damage. So what the big picture here is, when you see a charge of -1 coulombs, it's a lot of electrons. So how many protons are in an object that has +1 coulombs? Well, like an electron, 1 proton is equal to +1.6 times 10 to the minus 19 coulombs. So this is a very important number. That number is the elementary charge, and it's in your data booklet. Okay, we're going to be using it a lot. So 1 proton has a charge of +1.6 times 10 to the minus 19 coulombs. It's the same as an electron, but just opposite charge. Okay, so that would mean that, like an electron, I would apply the same thing. +1 coulomb times 1 proton over +1.6 times 10 to the minus 19 coulombs will give me 6.25 times 10 to the 18 protons. And that would tell me the number of protons, the same. Okay, so that's a lot of protons for 1 coulomb of charge. Now, let's get to Coulomb's law. Coulomb's law, like you would have read in the text, I'm not teaching everything. I want you guys to be using your online textbook. Coulomb's law looks a lot like Newton's law of gravitation. Newton's law of gravitation was this, if you remember. Okay, and Coulomb's law looks like this. Okay, that looks very, very similar, where F, the force between the objects, is inversely proportional to r squared. And that's called the inverse square law, which is associated with field forces. Any force that acts over a distance doesn't require contact. Gravity doesn't require contact. It acts over a distance. It's a field force. Okay, same as charge. It acts over a distance. Therefore, the force is inversely proportional to the distance squared between the objects, which is called the inverse square law, and it's a field as well. Very similar equation, which is very interesting for learning physics, that 2 different things have exactly almost the same equation. Now I'm just going to erase gravity, and we're just going to focus on Coulomb's law. So what is K? K is the universal constant, okay, which is 8.99 times 10 to the 9. I'm sure if you read your text, you'd find out a little bit more about where that number came from, and you need to find out what that is. I'm not going to put it here, but 8.99 times 10 to the 9, it's very huge, is K, okay? Q, oops, Q is the charge of object 1, and Q2 is the charge of object 2 in coulombs, and R is the distance separating measured in meters. This is in coulombs. And 8.99 times 10 to the 9 is dimensionless, and that gives me the force in newtons. Okay, so hopefully you've written that down. I'm just going to erase all this stuff that I put over here, and we're going to apply that in this little calculation that we have over here. So if I want to plug the numbers in, I would have 8.99 times 10 to the 9. Okay, now what this is I have one object and another object that are separated by a distance of 0.5 meters. That object is 1 microcoulomb, and this object is 1.5 microcoulombs. All right, so what's a micro? Now, if you go to your data booklet, you'd find a micro is times 10 to the minus 6. So 1.5 times 10 to the minus 6 coulombs, and you'd have 1.0 times 10 to the minus 6 coulombs divided by 0.5 meters squared. If I plug that into my calculator, now pause the video and make sure you're plugging it in your calculator to see if you can get the same answer. The reason I'm asking you to do that is there's a lot of scientific notation in here, and you got a square in there. I'm testing to see if you can do your calculator right. Obviously, if I'm telling you to stop, it's because a lot of kids don't do it right. So let's make sure you're punching in EE button, or the E button for scientific notation, so that it doesn't mess up the orders of operations. And if you did it properly, you would find out that the force is equal to 5.39 times 10 to the minus 2 newtons. Okay, so very, very weak force. All right, but for probably those types of objects are very, very small, that might be a force that would cause them to move. All right, and that brings it to a close. That's how you would apply Coulomb's law. This is how you would calculate how many electrons and protons. I can work backwards. If I know my number of protons, I can multiply by the charge of each one to find out the total charge that I have. And that should be enough for you to work on Tuesday's problem set. On Friday, we'll continue and talk about electric fields.